Tēnā koutou katoa. I'm going to give a brief presentation on some of the innovation occurring in the marine biosecurity space. As a marine scientist, I thought I'd better take that opportunity. First of all, though, I did want to acknowledge up front these people who are co-authors who have actually provided me with the information for this presentation and are actually doing all the work. So I'll give you, I guess, a brief introduction to marine biosecurity and its history in New Zealand, then touch on our New Zealand's craft risk management standard for biofouling, and look at some of the technologies and innovations underway that could help improve the outcomes that we are seeking to achieve with this standard. I'll also then talk about some of the technologies and innovations and research that's underway and being explored to improve how we approach marine surveillance as well. So it's very small, I apologise for that. So marine biosecurity is still in its infancy relative to other biosecurity sectors. It only really started receiving regulatory and government interest in the late 90s. And that followed some high-profile international incursions where ballast water was the implicated vector. These included the introduction of Vibrio cholera into Peru, which was linked to over 10,000 deaths. The black zebra mussel introduction into the Great Lakes in the US, and the introduction of the comb jelly, Nemiopsis, which was introduced into the Black Sea and caused a complete shift in the trophic structure and resulted in multiple fisheries collapsing. Some other key points in our history relative to what I'm going to talk to today. Our National Marine High-Risk Site Surveillance Program was initiated in the very early 2000s. And more recently, the New Zealand Craft Risk Management Standard for biofouling was introduced last year. It's a world first, so there's a lot of learning that's happening in that space as well, and this pretty much plugs the last major marine biosecurity risk pathway. And just for some context, this is a density map of vessel routes and movements into and out of New Zealand and Australia and our region for the last year. And it just highlights how connected we are via international shipping globally and regionally. And I frequently get asked, why do we bother about marine biosecurity? As a marine scientist, I'm very passionate about it. And I get asked, can we do anything about it? Do they actually have an impact? And I suspect that most views are on the basis that this is what most people see when they look at the marine environment. But it is a lot more complex than that. There's a lot going on under the surface, and there's a lot of value that we extract from the marine environment, and also that people take from the marine environment as well. So it's a lot more complex than just the surface. And these images just represent some of the examples of marine pests that have arrived in New Zealand recently and that we have responded to in some form. Unfortunately, these are all still here, and this highlights the importance of working to prevent them getting here in the first place, or doing more work to improve early detection so that if they do turn up here, we can find them early and maximise our chances of being able to do anything about them. And just in case you're wondering what biofouling is, that's biofouling. So the Craft Risk Management Standard for biofouling was only implemented last year, and the intent of the standard in its simplest form is that vessel operators will undertake preventative measures to manage biofouling before they get here, so that when they do get here they have a clean hull with no marine pests. Now basically what happens, I guess, in this process is they submit their pre-arrival documents. It's paperwork based. They are assessed on their risk, and then based on that assessment they will classed as either high risk or subject to some sort of audit, and it either passes the audit or it fails the audit. And this is the process, I guess, where we start to have some form of in-water inspection being required. Currently for larger vessels this requires a dive team. However, divers can be expensive. There are some dependencies around their availability, their levels of expertise, and of course there are some health and safety considerations as well. So there's a range of factors that can make it challenging to rely solely on divers as the inspection technique. And there is a need for innovative ways to undertake in-water inspections. Now, in terms of prevention, and And I'll just say I'm not talking purely about New Zealand here. We work very, very collaboratively across New Zealand and Australia and beyond in the marine biosecurity space. So I'm going to be stealing ideas from our Australian colleagues as well. So enabling vessel operators to proactively manage biofouling risks and better understand what jurisdictions require so they can actually meet our requirements before they get here is a key means of minimising marine biosecurity risks posed by biofouling. So Western Australia has done a lot of work on developing a cloud-based system called VesselCheck 2 that delivers an integrated real-time biofouling decision support tool for both vessel operators and jurisdictions that is easy and efficient to use. So basically vessel operators can upload all of their relevant biofouling management information into the system and get an immediate assessment on whether they meet the jurisdiction's requirements or not, as well as a steer on what they might need to do to meet those requirements now and into the future. This information is also instantly available to the jurisdictions that they will be visiting, who can then make use of this information well in advance of a vessel arriving to assess the risk and advise the vessel on actions required or to clear it based on the information provided. And it also provides a platform for jurisdictions to share intelligence and information on vessels and any prior interventions or observations that might have been made about those. Now, this is a very simplistic overview. The system is far more complex than this and more sophisticated. However, it does aim to make use of new technology and data integration to make life a lot easier for both vessel owners and jurisdictions, and ultimately improve marine biosecurity through better biofouling risk management. Now, Justin Mcdonald from Western Australia is here today, so he's overseeing some of this work and I'm sure is more than happy to talk about it. Oop. Sorry, I forgot about those. Okay, remote operated vehicles. So MPI has only recently begun exploring the utility of various in-water visual techniques as alternatives for divers verifying that vessels are clean and inspecting high-risk vessels as well. For smaller vessels like recreational yachts, the camera on a stick has proved to be very effective. Sounds very simple, but it's been evolved as actually quite high-tech, low cost and easy for a quarantine officer to use and apply in the field. However, this isn't practical for obvious reasons when you're looking at vessels at that size. So this is where we're starting to look at underwater platforms like remote operated vehicles. And MPI's tried a few smaller and cheaper ROV options, but these haven't so far proved to be fit for purpose. So we're starting to look at other, broader options in this space as well. Now, this is where, ROV technology and its application is evolving and improving exponentially. I mean, you've seen this with UAVs, so drones. I don't like to use that term, but that's the one that most people know. Costs are coming down. The systems are evolving and improving. The size of units is getting smaller. The technology and the software to maneuver those and to integrate with the various sensors that exist are also exploding. And as a result of this, uptake of this technology is increasing, and therefore innovation is increasing as a result as well. So following on from some marine biosecurity issues where they face some challenges when attempting to apply ROVs, the Tasmanian government has embarked on an Australian Department of Agriculture funded project to explore and evaluate the current off-the-shelf ROVs for marine biosecurity application, look at what adaptations can be made to those to make them more effective for a wide range of marine biosecurity purposes. And they've also designed a training program specific for marine pest surveillance users. So this is quite an exciting piece of work, and we'll be certainly keeping in contact with the Tasmanian government to see where that goes. Go back. So New Zealand has had a marine high-risk site surveillance program running for nearly 20 years now. This program was designed and is still delivered under contract by the New Zealand National Institute of Water and Atmospheric Research. It's undertaken in ports and marinas that receive international traffic across New Zealand, and it targets a suite of marine pests using a wide range of sampling or detection methods. As you can appreciate, there are a number of challenges in operating in and around ports, and as a result, NIWA are continually looking at how to improve the effectiveness and efficiency of this program. Safety is also a key area of focus, and ports have their fair share of health and safety hazards. I guess an example here in Auckland is we have a leopard seal that's taken up residence in the Waitemata Harbour, and for health and safety reasons this has impacted our ability to do dive surveys and therefore achieve the objectives of the program. So ROVs are one of those areas that are being explored in the marine space. In addition to overcoming some of these health and safety issues, ROVs offer an alternative surveillance tool to complement existing methods that can be easily deployed and are highly effective when combined with high-definition cameras, good survey design, and potentially automated image analysis software as well. And NIWA are doing a lot of work on ROVs to understand their detection efficiency, comparing them against diver surveys, looking at them under various conditions, their cost per unit effort, 3D image reconstruction, and a whole range of other innovative applications as well. And they are also working very closely with a local ROV provider, Boxfish Research, to explore new technologies and innovations. And they're also sharing information and collaborating with the Tasmanian study that I touched on earlier. Another area of, I guess, potential is sonar. So in marine, I guess, marine surveillance is generally undertaken in ports. The methods are largely visual, and as I'm sure you can appreciate, ports aren't the cleanest, and they are quite turbid as well, so the water is very murky and hard to see. So there are opportunities to combine sonar technology and ROVs to improve both navigation and geolocation of these units underwater, so you don't lose them or run them under the wharf, but also potentially looking at biofouling and species detection as well. And work is already underway and planned looking at this potential both here in New Zealand with NIWA and in Tasmania as well. And we heard a bit about molecular technology earlier. So advances in molecular diagnostic techniques offer huge opportunities across the board in the surveillance space. I'll talk a bit about the marine stuff. In New Zealand and Australia, there's been a lot of focus on how to move from all the hype around this new technology to actually developing and operationalising practical, cost-effective and credible marine surveillance tools. Here in New Zealand, NIWA and Cawthron have been working collaboratively for several years under various internally and externally funded research programs looking at how to operationalise these here in New Zealand, developing new tools and techniques, species-specific tests, validation, survey design, building and contributing to species databases, but also looking at some of the challenges and limitations that exist. And these need to be overcome before we can actually fully operationalise this technology in a credible and in a way that we're confident with the results as well. In Australia, they've gone a step further. They already have implemented marine pest surveillance programs that solely use molecular diagnostics on water samples or settlement arrays, and they're learning a lot about, I guess, the application and innovating from what they're learning. But recognising the opportunities around collaboration in this area and other marine biosecurity topics, NIWA instigated a few years ago a collaborative research and development initiative with MBIE funding to bring together scientists from and regulators from New Zealand, Australia, the US and Canada to work together on developing and implementing these tools effectively, amongst a whole range of other topics as well. And again, fortunately, we have Graham Inglis from NIWA, Javier Pochon and Anastasia Zyko from Cawthron, and Justin Mcdonald from Western Australia, who are all part of this collaboration. And I'm sure are more than happy to talk about some of the cool work that they've been doing in this space. And just in summary, so there's a lot of innovative work that is happening in the marine biosecurity space. This is just a very small snapshot of some of the work and the collaboration and information sharing that is going on. And collaboration and information sharing is going to be critical to reach the outcomes we are seeking. It's also important that new approaches and innovations can be practically, cost-effectively applied, and that they are credible and have a good science basis to support their application as well. Thanks very much.